Good morning, students. Today I am going to start with the next chapter, current, electricity.
Today, he and Rachna went to the market and then returned home. Aarti switched on the fan and the bulb. The fan was running at low speed, so Aarti rotated the regulator of the fan at its high speed. Rachna asked Aarti that how did the speed of the fan increase as you just rotated the regulator? How does it work? Aarti replied that the regulator of the fan works just like a variable resistor. At initial position, resistance was very high and the speed of the fan was low. But when I rotated the regulator, its resistance decreased to its minimum value and hence the speed of the fan maximized. It means that as the value of resistance decreases, the value of electric current increases. Students, today we will study more about the current electricity. Objectives. At the end of this lesson, you will be able to define electric current, understand electric current in conductors, define Ohm's law, calculate resistivity, know the limitations of Ohm's law, determine resistivity of various materials, evaluate temperature dependence of resistivity, define electrical energy and power, evaluate combination of resistors, understand cells and its combinations, state Kirchhoff's law, define Wheatstone bridge, meter bridge, and potentiometer.
So these all are the topics which we are going to discuss one by one. For today's session, I am going to take the define electric current and understand electric current in conductor.
Electric current. The electric current is defined as the time rate at which charge flows through a surface area. Let in time delta t, a net charge delta q flows through the area. The average electric current is given by delta q upon delta t. If the flow of charge is not steady, then the instantaneous electric current is given by dq upon dt.
Now the electric current is defined as the time rate of change which the charge flow through a surface area. Means if delta t time, in delta t time, small delta t time, if the dq charge flows through the area A. This is an example of a conductor. The average electric current is defined as I is equal to dq upon dt because it is a rate at which the charge flow. If the flow is not steady, means the flow is not steady, somewhere is more, somewhere it is, sometimes it is less, then the instantaneous मतलब एक पर्टिकुलर इंस्टेंट पे आप इलेक्ट्रिक करंट निकालना चाहते हो, दैट मीन्स आई इज इक्वल टू डी क्यू अपॉन डी टी लेते हैं.
The SI unit of current is ampere. The current is in the direction opposite to the flow of electrons. The direction of electric current is taken to be in the direction of flow of positive charges.
Now, the direction of current opposite to the direction of flow of electrons. Electrons flow from negative to the positive charge, and the direction of current taken to be in the direction of positive चार्ज मीन्स इलेक्ट्रॉन्स तो आपके नेगेटिव से पॉजिटिव चार्ज पे मूव करेंगे, बट करंट उनके अपोजिट डायरेक्शन में मूव करता है फ्रॉम पॉजिटिव टू नेगेटिव चार्ज.
Electric current in conductors. For a current to flow in a conductor, a potential difference must exist across it. The current flows from high potential to low potential. When a battery is connected across the ends of a conductor, the surface charges of opposite sign build up on the conductor starting from the two ends in contact with the battery terminals.
Now electric current in conductor. Let us assume you just take a conductor. For a current to flow in a conductor, a potential difference must exist. तो अगर आपको current को flow कराना है, that means you want to move the positive charge. The potential difference must be applied. Potential difference means we have to apply a battery. Battery हमें लगाना जरूरी है. The current flow from high potential to the low potential means if this is a battery, तो इनके बीच में अगर potential difference, the positive charge is the high potential and negative charge will be your low potential. When a battery is connected across the end of a conductor, the surface charge of opposite sign build up on the conductor is starting from the two ends in contact with the battery terminal. So when we connect the conductor, suppose this is a conductor, or if you want to and when we connect it with the battery positive, so due to this potential difference at the end of the conductor, because of this positive sign, यहाँ पर आपका positive charge automatically develop हो जाएगा, and here because of this negative, at this surface negative charges automatically develop here, and because of this charges, surface charges, here the positive charge is collect here and negative charge will be appears here. The electric field is from positive to negative end.
These surface charges produce an electric field. This electric field causes electrons to move in a direction opposite to that of the field. Direction opposite to that of.
Not because of this battery. The electric field is from positive to negative charge, and since the negative charge, that means the electron are more in this area. तो यहाँ पे क्या है, इलेक्ट्रॉन का एक क्लस्टर हो जाएगा, बहुत सारे इलेक्ट्रॉन इकट्ठे हो जाएंगे यहाँ पर बिकॉज ऑफ दिस कंडक्टर. तो यहाँ पे जब इलेक्ट्रॉन ज़्यादा हो जाएंगे तो दे स्टार्ट colliding with each other, or because of that collision they start moving in the direction opposite to the electric field from negative to पॉजिटिव चार्ज. क्योंकि यहाँ पे इलेक्ट्रॉन ज़्यादा है तो इलेक्ट्रॉन डेंसिटी यहाँ पे ज़्यादा होगी और यहाँ पे कम होगी. तो इलेक्ट्रिक फील्ड इज फ्रॉम पॉजिटिव टू नेगेटिव, बट इलेक्ट्रॉन मूव फ्रॉम नेगेटिव टू पॉजिटिव.
Of the field. Due to collisions, the electrons move slowly along the conductor and their average velocity is called the drift velocity Vd. This directed flow of electrons constitutes a current.
Now at the surface जहाँ पे नेगेटिव चार्ज था, ड्यू टू द कोलिजन वहाँ पे नेगेटिव चार्ज बहुत जल्दी इकट्ठा होने लग जाएगा बिकॉज ऑफ द पोटेंशियल डिफरेंस विच इज अप्लाई फ्रॉम द बैटरी. द इलेक्ट्रॉन मूव स्लोली अलॉन्ग द करंट, धीरे धीरे वो मूव करना शुरू करेंगे, और द एयर एवरेज वेलोसिटी इज कॉल्ड एज द ड्रिफ्ट वेलोसिटी. जस्ट रिमेंबर व्हाट इज द ड्रिफ्ट वेलोसिटी. इट इज द एवरेज वेलोसिटी ऑफ द इलेक्ट्रॉन्स when we apply the potential difference across the ends of a conductor. This directed flow of electrons constitute a current, और जब ये electrons move करने लगेंगे तो that will constitute a current. तो इलेक्ट्रिक फील्ड के अपोजिट, अगर अब इलेक्ट्रिक फील्ड इस डायरेक्शन में लग रही है तो ड्रिफ्ट वेलोसिटी ऑफ द इलेक्ट्रॉन इज इन दिस डायरेक्शन, दैट इज अपोजिट टू द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. तो टुडेज सेशन इज ओवर. विल कंटिन्यू दिस सेशन इन आवर नेक्स्ट क्लास. Good day.